Hello and welcome to this topic on oxygen for the Airbus A320, part of the Gen Fam. We are going to have 4 sessions that we're going to cover. Session 1 is the overview of oxygen. Session 2 is on portable oxygen system. Session 3, the passenger oxygen system. And our last session, session 4, is on the flight crew oxygen system. Of course, oxygen is in place in case that we have a cabin pressure drop, and therefore also oxygen depletion. This enables the flight crew as well as the passengers to maintain that oxygen level for their survival and sustenance with the oxygen masks that get deployed. So that's a general overview on that. There are different kinds of oxygen masks, and I'm going to talk a little bit about or describe each of them when it comes to the flight crew and their oxygen masks compared to the passengers. Portable, you may or may not see that on some of the models or variants of the aircraft, depending on which one you are working on. But on the portable system, and I'm going to go ahead and move on to session 2 at this point. Session 1 is just, basically the oxygen system is there, and those are the different aspects that we have to the systems as far as its applications. The portable oxygen system is mainly for being able to obviously be portable, right? To transport with it without too much cumbersomeness, just being able to handle a container or canister of oxygen while being mobile on the aircraft. And so these portable oxygen systems are available to the cabin attendants so that they can administer oxygen in an emergency to either passengers or crew. Now, the portable oxygen system is containing portable devices for the flight crew as well as for the cabin assistants or attendants, excuse me. So like I mentioned before, it depends on the variant of your aircraft. Some of them actually have the protected breathing equipment, some of them do not. Okay, that's the portable system that I'm talking about right now. Obviously, it's supplying oxygen for the crew members in case there's a fire or there could be smoke also in the cockpit. Rick has experienced that. He can talk more. If you haven't heard his video on that, be sure to do that just to get a feel from the pilot's perspective and experience of having smoke in the cockpit and having the deployment of oxygen masks in that particular situation. This is what you have here with the oxygen, as far as the breathing equipment. Okay, that portable, being able to be used when there's smoke, or maybe there's a particular gas that has a scent or some kind of a smell to it that's not normal. Then you want to be able to, or they want to be able to have oxygen masks in order to fly the plane safely. Right? All right, so you have that. Now, your portable devices for cabin attendants, those are installed in different places in the cabin. Mainly, you're going to have them at where the attendants actually sit down. So there are some there. Also in the galley areas, you can find them in the cabin stowage and also the overhead stowage area. Okay, if you're ever tasked with switching out any kind of brackets, or because one of the things that you on an airplane obviously is making sure things stay put when they should. So with the stowage of oxygen systems, in these containers that are under pressure, they need to stay put when they're not in use. And if they're on brackets to secure them there, you want to make sure that those brackets are intact and not loose. Being able to do replacements of that, just follow obviously the instructions by the manufacturer in replacing not just the container, of oxygen, but also being able to replace brackets that may have come loose, or maybe they're not in good shape, so you want to replace them altogether. Just be aware of those different items that pertain to keeping the oxygen tanks in place. And incidentally, you do have expirations on these tanks. They can't just last or stay there and be in optimal use forever. They do have expirations on them, so you obviously need to remove those if they are expired, and do follow procedures. You are handling pressurized gas, and you want to make sure that you follow specifically all the instructions regarding the removal of those tanks. All right, so that's what we have on the on the portable oxygen system. The canister itself is pretty standard across all of the other, just when we talk about flight crew oxygen or passenger oxygen tanks, you're going to have the same components related to that. And those are going to be your pressure regulator. You're going to have a relief valve for low and for high pressure, and of course your outlet connections and a strap to secure it when it's not being used. Okay, or when it's needing to be, you don't need to remove it, you just leave it there. Any kind of bracket or securing device needs to be intact. The oxygen masks themselves, when it comes to the portable or the other ones, are just going to have the face piece. You also have the valves that are for exhalation and inhalation. And incidentally, the biggest threat to the face masks are going to be dust or lint, right? Just anything that can settle in those valves, and you want to make sure those are clean if you're tasked to do that. So look out for dust and lint and clean them accordingly per the manual. You also have a flow indicator on these. Because you want to make sure those are working so that they're reading the right. Obviously, there's a good reading and not a bad reading. So that's pretty much what you have with that. And of course, there are diagrams to show you if you've never seen oxygen mask. It's okay, or if you haven't seen an actual container. All right, so that's all that I have to say for the portable oxygen system. That concludes session 2. I know these are very short, but it's a familiarity with what you probably have already been introduced to at some point in your career. All right, let's go ahead and move on to session 3. This is going to be on the passenger oxygen system. I purposely leaving the flight crew oxygen to the end of this presentation instruction, because if the flight crew is passed out, who's going to fly the plane? We need to make sure that flight crew have enough oxygen in an emergency situation so that they can have their wits about them and be able to bring that plane down safely for everybody on that plane. So let me go ahead and cover passenger oxygen, and then we'll finish out this topic with the flight crew oxygen. Okay, with passenger oxygen, you're going to have these, obviously they're located, you're going to have these installed above the seats, okay, above where the passengers sit. So those are those little cutouts that where those masks are located. You're also going to have them in the lavatories and also in the galley areas, like the work areas for the cabin attendants and the stations. All right, and just be aware that this is obviously in case there's a sudden loss of cabin pressure, that these oxygen masks will automatically deploy. And the supply, just to have an idea, the supply of the oxygen is for about 15 minutes of that emergency oxygen. The generators themselves, okay, we're talking about the tanks or the cylinders. Those are obviously supplying the oxygen to the masks. These masks in particular are the continuous flow. Okay, now this is to differentiate from demand or on-demand mask. If you've never heard this before, just note that the difference here in continuous flow obviously means that you're going to, once deployed, it's going to have a continuous flow of oxygen without stopping. The on-demand masks are meant for the flight crew. because it's a way of conserving. If it's not necessary to have, or actually it's only when they're, you know, taking in or inhaling, that's when you have that oxygen that's available for the flight crew. Again, the whole idea is just efficiency, because the most important people, and relatively speaking, the most important people on the plane are the people who know how to fly that plane and land it. So that is why we want to have an efficiency even more so with the flight crew oxygen system. The lavatory, back to passenger, with the lavatory oxygen containers, those have a pull flag assembly associated with that. All right, and just to kind of give you a little rundown on the, you know, actual components involved. There's an oxygen mask assembly. You've got the door, the generator. You also have a supply hose that's going to supply the oxygen from the generator to the mask itself. When the person puts the mask on, it creates a seal there. There's also a test button, so if you're ever assigned to testing the oxygen systems on board the aircraft, you know that there's a test button when you open up that door where all those components are for that oxygen system. The generator itself is going to be across the board for all the generators, but these are have a core. I mean, I don't know how important it is to you to know what kind of chemical compound it is, but it's sodium chlorate. It has a sodium chlorate core that has a steel housing around it, right? And of course it's insulating material, so you have that containment. You've also got a striker with a percussion cap that's installed at one end of that housing, and then you have a pin. So you've got different components associated with this that need to be looked at, because if you have one component that's defective, it's maybe dirty, then it's obviously going to affect the rest of the components and their operations. You have a filter assembly, of course, and remember I mentioned about lint and dust. You know, they can get caught in the valves, in that valve area, so you want to make sure that you do visual inspections of that. There is a filter assembly, so you know that is obviously to filter out any debris, but you know there can be a faulty components regarding that, so that you know you still have a buildup somewhere. Okay, so you have this filter assembly. It's installed in the outlet end of the housing. Obviously, you want to protect the oxygen supply that's going to people, and that is what that is there for. You also have an indicator on the housing. The colors that are involved with the indication here, and we're talking about there's a relief valve that's installed because we don't want to have a high pressure buildup, just in case that we have an outlet valve that fails. If the outlet valve fails, then you're not going to have an expenditure rate of the oxygen. You'll have a buildup of it, and then that's a problem. It's going to create a higher pressure situation. Now, there is an indicator, like I said, that will change. So here are the colors, but they'll change from yellow to black when the chemical oxygen generator has been fired. So once it's been deployed, you're going to have a black on the indication. And if you're going to do maintenance, of course, on anything, just when we talk about lockout, tagout, this is on the safety side, so you probably have come across this in safety meetings that you've had, hopefully. But you know, you want to install safety rings and any kind of safety pins if you're going to move the generators around. Because again, right, it's a cylinder under high pressure, or some amount of pressure, and you don't want to have, when you're handling it, you don't want to have it get deployed. So these safety rings or pins are going to hopefully, but you know, they're there to prevent that. But always maintain your own safety, that just in case something fails, safety fails, you're not in, quote unquote, in the line of fire. Make sure you're handling them so your face is away from any place where when you're handling that, where it could just go right into you. I teach in another arena, and I tell people, do not always rely on the safety mechanisms of equipment. All right, this gives you an idea a little bit more on the generator. Pretty standard with what I just mentioned. Your outlet valve, relief valve, your release pins, and of course it's a steel housing, and of course you have also a core there in the middle. Your mask and door assembly. Remember I mentioned there's a test button in there. Okay, so when you're opening it up, you want to test it to make sure that you have this functioning oxygen assembly where the supply hose is not stopped or something's not preventing the flow of good oxygen going to those masks. You do have also the inspection, visual inspection of the oxygen masks that are part of your testing. But the oxygen mask itself is just a base cone with the bag, right? You may have seen that, the bag that's attached to it. And you've got the different valves that are installed in that face part of it, okay, that has the reservoir. You got a flow indicator, okay, that's installed in the flexible hose, which goes to the oxygen mask from the generator. If everything's a go, everything's good, you're going to have the flow indicator to be green. So green color means everything's good, as it is on many other applications. Your door and latch assembly, that's obviously going to hold the door of the oxygen container to keep it closed. It's under spring pressure, and that will actually open the door when you have the release of the latch assembly, which is, by the way, electrical. Remember I mentioned about the test button that you have there. That's going to allow the door to drop slightly without the whole oxygen mask coming down, because you just want to testing the electrical circuit actually to make sure that it will open up the door, which obviously gravity at that point just allows the masks to fall. So that's what that's doing. Your test button, it's not just a push button. I know there's different kinds of test buttons. This in particular is the pull down type. So to activate it, you have to pull down the release tool and then turn through, you got to turn through it 90 degrees. Okay, and there's different, follow the instructions specifically, because there may be some slight differences in the instructions. There's some similarity across, but then there may be a few things that might be different in your step-for-step procedure, depending on which aircraft model variant. So not just the model of, oh, I'm working on an A319. No, but which series. You got 319 whatever through, 350 or through whatever. So please just pay attention to, and make sure you have, that sounds kind of silly, but make sure that you do have and check manuals that are on your computers. And on your computers, meaning you have access to, just as a double check. Anything, just see, make sure it is the manual that is the one for the aircraft that you're working on. And with the controls and indications that you have, some of the things that you're going to see on the panels in the cockpit are going to be mask, man on, and then you'll also have your TMR reset. Okay, that allows the pilot to reset the controls after the operation has happened. So that's just a reset button. Okay, so just to be aware of a few things that you'll see there on the cockpit, as far as indication goes. And as far as your operation, it's electrical. So just in general, it's an electrical circuit, and therefore you've got to have a trigger, right? Just like with all of the things I've been talking about that you've been learning about, you have sensors, and sensors are going to send information. They're going to send signals, and that are going to be translated as along that circuit into a way for the pilots to actually read it on the ECAMs. With here, the cabin pressure, if the cabin, remember I'm talking about cabin pressure, if the cabin pressure drops to an equivalent, okay, this is to an equivalent, because we're talking about a cabin altitude, but we are talking about pressure, but if that drops to an equivalent about 14,000 plus, give or take maybe 250 to 700 feet, then the altitude pressure switch is going to be activated. Okay, this is all electrical. So then what happens is you got activation of relays. And the relays are going to be a chain reaction to allow the containers to open the doors and allow the mass to drop. Okay, so they can be used. So just so you know, if you're an avionics technician, then you're really interested maybe, but if you're not, probably don't want to know specifically. And I typically don't like to mention specific relay identifiers because it could be different if you're working on perhaps some other aircraft. So just know you've got an electrical circuit, you have relays in order to relay the information so that we can have activation of the system itself. Of course, when that you can also have a fault light that's going to come on, the fault light on the 50 VU panel, okay, is going to come on. And when does that come on? That's going to be triggered by either a 30-second delay of one particular, 30 seconds for one relay, or if another relay does not energize. So just know the fault light will come on if a couple of things will happen electrically. There's also manual operation bypass. That bypasses the 30-second relay, 30-second relays. Because you have two relays involved in this particular one. There's more, but there's two in particular that are mentioned. Again, I don't want to say the numbers because, again, I don't want to cause confusion, but there are two 30-second relays. They're programmed for that. And if you ever if you're into reading electrical diagrams, never mind just regular schematics, but electrical diagrams that'll give you a true electrical picture, and not just for teaching purposes, because certainly you can look at some of the things that you might see in a manual, you know, for just kind of getting a brushstroke understanding of it, or of the circuit itself for that particular model of aircraft. But there are more detailed ones, and those are the ones you really want to look at. Again, of course, if you're an avionics technician, you'll know what I'm talking about right now. All right, that pretty much covers your passenger oxygen system. And now we're going to cover our last session, which is session 4 on the flight crew, because like I mentioned before, and this is not to say that other people are not of value, but let's face it, the pilots, we want to make sure, I'm sure every passenger wishes and always makes sure, or wants to have peace of mind, that the flight crew is intact mentally, physically, right? Everything else under the sun. So let's go ahead and go into that and understand a little bit more about just a slight difference. I mean, there's some differences with the oxygen system with flight crew. All right, so what I'm talking about with the flight crew oxygen system is this is going to be a little, remember I mentioned about the masks being a little bit different. The masks are going to be, they're full face. They're not like the passenger masks, which are just kind of the nose, you know, just kind of the nose and the mouth area. But the, you know, for the pilots, those are going to be a full face oxygen mask. Okay. All right. So let's look at some of the aspects to the masks. Remember I mentioned before about how the flight oxygen for, the oxygen for the flight crew is what's called a demand, or like on-demand mask. That's what you have. It's a demand regulator installed. So it's as the oxygen is needed. So they're not just it's not just continually going when they don't absolutely need it, because they need to have it last a lot longer than passengers. Again, the job is just to make sure that the flight crew have what they need with enough time to bring down the plane. Okay, so that's why you have a regulator with the demand. Demand regulator with the masks for the flight crew. Okay, and then you do have a crew supply switch on the 50 VU panel. You'll see that also next to the passenger as well. All right, and just a caution, or I should say a warning, because we're dealing with pressurized gas. Again, I know I'm repeating it, but it's very important that you treat these canisters with respect, no matter how many years that you've been working maybe on these, or been around airplanes, because I know from experience with teaching for 18 years now, that in a very high threat environment, is that with equipment, and you do not take anything for granted, and it's just like flying a plane. I mean, I could liken it to something else, but this is for flying a plane. Oh, you've flown so many times. Well, yeah, but you still have a checklist. You still go, because you never know what kind of day you have. Your mind may wander a little bit, and you thought you did something when you didn't. So important to pay attention to warnings that are posted, and just for your own mental thought, you want to keep all of these chemicals, including lubricants, right? So not just oil, but you have synthetics that are also lubricants, and fuel. You want to keep that all away from any place where there's oxygen, right? Because then you're going to have an explosive environment, and we don't want to have that. So do make sure that you're being very cautious and just aware of all of that when you're doing that. Also, with the tools that you're using, make sure that your hands are clean, because you don't want to prevent, you don't want to have a contamination with what might be on your hands with the way you're handling the oxygen tanks or containers. Okay. All right, I know I went off on a track, but it's a good track because this is about your safety. So, all right, so back to the flight crew. With the oxygen cylinders, the assemblies that you have, these assemblies, these oxygen cylinder assemblies are located in certain frames, and they're actually in the left of the avionics compartment. Okay, so you'll find it there. There's the same type of steel housing that you have with the passenger oxygen containers. And those are also a very high pressure steel cylinder. Your capacity is about 115 cubic feet with the flight crew containers. There's also a pressure, just to give you an idea. You don't have to necessarily memorize this. Well, you don't have to memorize anything. But just to give you an idea on pressure, it's at 1,850 psig. All right. Then your cylinder has a valve assembly, of course, because you're also going to have those relief valves, like we had on the other one. There's a manual slow opening on and off valve, so you have that. You also have a pressure gauge on it, and then a safety outlet. Okay. Now on your valve that is the slow opening one, there's a metal seat and a poppet, and that's just to reduce the explosion possibility. Okay, you don't want to have that, so there's a way for it to prevent that. You also have a direct reading pressure gauge. That's just going to obviously measure the pressure in the cylinder. All right, and then when you're working on these things, if you ever are, do open up the manual shut-off valves, and you want to do that very slowly. So that's just a big tip right there, is when you're handling these things, be very slow and deliberate with when you're opening these shut-off valves. All right. I'll talk a little bit about the regulator, because again, like I said, you have this with the flight crew configuration. The pressure regulator and transmitter reduces obviously the pressure into the usable mass pressure. I mean, you have that, even with the other, with the passenger, is that there has to be a way, because it's all this pressure right inside the cylinder, but you don't want to have the same pressure coming out, at full force into this, supply in the supply hose that goes to the masks. Don't want that. So that's why you have to have a regulator. So it basically is reducing that pressure down so that it can safely be that oxygen can safely be supplied through the hose to the masks. Okay, and your location for the pressure regulator transmitter, that is in the avionics compartment, and that is directly connected to the cylinder. Okay, you also have an outlet, the high pressure safety. It's a safety outlet. It's right on the cylinder head. You also have the low pressure safety outlet that's on the regulator. Okay, and those are both connected to the discharge indicator. So, so the indication can be, so it can indicate the pressures that are available or that are there. Of course, you have the discharge indicator that has a green blowout disc, and that can be seen from outside of the left fuselage skin. Now, what's going to trigger the blowout? Okay, the disc will blow out at a pressure. It's going to blow out at a pressure of 40, roughly 40 to 100 psi G, to show a yellow indicator. Okay, and that just means that the oxygen has been discharged. Okay, now remember, green means success, yellow. Yellow, if you have the yellow indicator, that could indicate that you may have to replace a component. So which one? Well, you'd have to test to see which one it might be, whether it's a regulator or something else, but just be aware that you have indicators in the head, in the cylinder head, with the pressure regulator there and transmitter. Your supply valve, this is just going to allow the flight crew, okay, and maintenance people like yourself to select the supply of oxygen on or off, as it's needed. Okay, and that's as needed from the flight station. Okay, you could have leaks, and that's one of the things to be aware of. Maintenance with this whole oxygen system is that, anytime you have a flow of something, and this is fluid power, by the way. You have fluid power. I'm thinking about, when you have oxygen, there's always that chance of having a leak somewhere. Okay. All right, and then of course you got solenoids. That's all part of your electrical part of things. Okay, being able to have the low pressure supply valve operate, because it is operated electrically, and then of course it's controlled from the switch in the cockpit. So you have that. All right, there's also a manifold that you have. It's a distribution, we have supplies, supply and distribution manifolds. In this particular case, we do have a distribution manifold and also a low pressure switch. But I wanted to emphasize that we do have a component that's the distribution manifold, and this is used to decrease the possibility of leaks that may be in the system. So that's just helping with the distribution manifold, it's kind of creating almost like an even distribution of air, so of oxygen, in case that maybe there's something faulty somewhere that hasn't been, readily identified. Then it's kind of helping itself, if you will, with the distribution in order to get, to meet the demands of the oxygen. You've got pipes that are connected to the manifold, of course. One of them is supplying the oxygen to the captain. Okay, and then you also have another pipe that's supplying the first officer as well. Your low pressure switch is right on the distribution manifold, and it's actually operating when you have a supply pressure that decreases. All right, so low pressure switch is going to be triggered because the pressure is quote unquote low. And what is that defined as? When we say low, we're getting down to now 50 plus or minus 5 psig. Okay, then what it's going to do, that switch is going to transmit a warning signal to the ECAM in the cockpit. Okay, you also have a test port for testing the distribution manifold. So you can do your pressure tests on it as well as leaks. So that's pretty cool. You've got to have something where you can test both of those aspects. And just for the record, as far as maximum pressure that you can use at the test point, as a general rule, max is 145 psig. Okay, and of course the distribution manifold and your pressure switch are not going to be far from the oxygen cylinder, so they are near that oxygen cylinder. All right. Okay, so it gives you an idea on that. Like I said, I already mentioned the masks. Now, there's also a stowage box assembly. This is where the masks are stowed for the flight crew. There's two doors instead of the one. Like the one that you have for the passenger is just it's one door. Remember I said you just hit, it's a pull down type on the test button. And when you're doing that, it just barely, like just enough to get that electrical circuit, going so that it actually releases the door, but doesn't allow the mask to actually drop down. You have the same here similarly with the pressing of a test button, and of course also the reset. But in this particular case, there are two doors on the stowage box for flight crew masks. All right. These are, and of course the hoses are obviously flexible, that are used to distribute that oxygen to those masks. Okay, and of course those assemblies, your box assemblies, are in the cockpit, and they are next to the flight crew stations. Okay, all right, that pretty much concludes the oxygen. That gives you an idea, at least again, the helicopter's view, and a little bit of detail on the regulator, or the regulation of the oxygen coming from the cylinders and being supplied to those masks, whether it's to the passengers or the flight crew. All right, and of course you have portable oxygen systems. Just check the model of your aircraft. It may or may not be present there, but at least there's there's smaller canisters, obviously, so they can be moved and carried with a lot more ease. So that pretty much covers that. Let's go ahead and go to some test questions, so that you get an idea on what might be on the test regarding oxygen. All right, from session 1, so let's kind of give an idea on questions from session 1. What is a demand flow mask? Okay, two choices. Is it a flow of oxygen that happens only when the mask is donned on the face, or a flow of oxygen that happens when the operator pushes a button on the side of the mask? Okay, well, it's A. It's certainly not B. All right, what type of masks are the passenger? And actually, the demand flow, okay, or on demand, your demand flow mask, mask can be kept on, but it's triggered by inhalation. So just so you know, you can actually keep it there on the face. What type of masks are the passenger oxygen masks? Okay, are they A, continuous flow, or B, on demand, or demand flow? Okay, I mentioned this, it's continuous flow for the passenger masks. All right, what is a continuous flow mask? Okay, a flow of oxygen that happens irrespective of the mask being donned by the operator. And what I mean by that, it's really more just inhaling. I think once I take a breath, then it triggers it. Or is it a flow of oxygen that exists when the masks are in the stowage box? Well, it's A. Okay. Session 2 on portable. There's only 2 questions here. You probably just only have 2 questions on the test. The flight crew, okay, number 4, the portable oxygen system is for both the cabin crew and the passengers. Is that true or false? That's true. Number 5, the flight crew portable device is installed in the console at the left-hand aft bulkhead of the cockpit. I didn't mention it specifically, but that's a true statement. All right, let's go to a couple of questions for session 3. Number 6, at what approximate cabin altitude does the passenger oxygen get activated? Is it at 20,000 feet or 14,000 feet? It's 14,000 feet. Number 7, what is the security measure to take when transporting or storing the chemical oxygen generators? Is it A, safety rings or pins must be installed, or B, wear chemical retardant suits? All right, that's option A. That's correct, is A. Session 4 questions, just a few here. You can read the rest of them. 8, what are a few components of the flight crew oxygen distribution circuit? Is it the full-face quick donning masks and low pressure supply? Or is it pressure regulator transmitter and high pressure supply valve? Okay, it's A. All right, number 9, why does the oxygen system exist on commercial aircraft? Okay, A, mainly for the passengers previously identified as medical patients, or B, to provide supplemental oxygen in case cabin pressure decreases. I hope everybody got that right. That's letter B. Okay, let me go over a couple of ones here. All right, the next one, how many different oxygen systems are there on the Airbus A320 aircraft? At least what was taught, what I was mentioning to you. Okay, the answer is 3. Number 11, what is one warning that maintenance personnel should know? Is it making sure that the metal or plastic plugs put on all pipes are dry and clean? Which, by the way, you should do anyway, okay? Or is it B, making sure that he keeps fuel, lubricants, and materials defined as hydrocarbons away from the oxygen system? Okay, that would be the B, right? All right, last one, and we'll call it here. Where are the storage box assemblies located? Is it near the wing exits in the back of the plane or next to each flight crew station in the cockpit? Okay, that's letter B. You're right. All right, that concludes our topic on oxygen for the Airbus A320 aircraft and family there. If you have any questions regarding oxygen, please feel free to email us, and we'll do our best to get those answers to you. Thank you for participating, and I look forward to having you in the other videos.